Hey kids, Charlie Busser here again. We're going to be doing the Doritos experiment. I have some Doritos right here. And this is thermochemistry. And we talked about how the Doritos, which are food has energy in it. We measure food energy by a unit called calories, which is actually kilocalories. They are 1,000 little calories. Our job today is to use a Dorito to measure how much food energy is in it. Now we could eat it and let the biochemistry happen and release all the energy. It's very hard to measure that way. What we're going to do instead is we're going to burn it. Now, by burning the Dorito, we're going to release the energy in it. But it's going to be hard to measure how much energy comes out of it because it's a burning chip. But there is a way to do it called using a machine called a calorimeter. The calorimeter can also be said more slowly, calorimeter. And a calorimeter is a fancy device that's very well insulated and very well designed to burn food and measure all of the heat energy that comes out of it. I don't have one. I do have an empty can of seltzer though. We're going to use this empty can of seltzer as a calorimeter, along with this cool piece of aluminum foil to kind of reflect the burning heat into the can. So there are some details we have to get. We're going to all be using an empty seltzer can. I have to get the mass of that. I have a scale right here out of view. And the can weighs 12.77 grams. And now I have to put some water in it. I'm going to use a funnel to put some water in it so that I get all the water that I want in it and not on it. It doesn't really matter how much water I use. It doesn't really matter how much water I use because what's going to happen is the Dorito is going to heat up the water. And we're going to measure the water. We're going to know the temperature to start and the temperature to end. We'll have a delta T. We'll have the mass of the water. I know the C value for water because it's a constant. And I'll be able to calculate with the temperature change what the amount of joules it takes to heat this water up. Now, where'd the heat come from? It comes from the Doritos. So I'll be able to, you'll see how the math works. Let me weigh this can of water now because I have to know the can weight also. It's 161.46. Now I'll be able to do a little bit of subtraction later and I'll show you these numbers. I'll share them with you. I have a glass stirring rod and I'm going to put this glass stirring rod through. Let me turn this. Can you see that? I got this glass stirring rod through the ring stand. So the can is now hanging in there. And I have a thermometer that I'm going to stick in here. And I'm going to let that thermometer get the temperature of the water. Now, thermometers, they work really well, but they're not instantaneous. The kinetic energy in the water, the movement of the water, has to either transfer into the thermometer if the water is warmer, or if the water is colder than the thermometer, the energy from the thermometer has to transfer out till they become equalized. And when they become equalized, the thermometer, which has that blue alcohol in it, the alcohol will start moving at the same rate and it will expand or contract to a certain level, which we've already pre-indicated by the thermometer has lines on it. When it shakes this much and expands this much, that's the temperature that we call it. So we got to give it a moment. We're going to write down the starting and ending temperature of the water. We also need, I have one chip here, one Dorito. Looks better against my black shirt, I guess. I have to know the mass of my chip. And I'm going to put that down. And my chip is, ooh, wow, look at that. 2.50 grams exactly. Isn't that weird that it comes up just like that? Every time I go to Wegmans, and I go to Wegmans all the time, if my bill ever comes up to be like $74 even, I always find that so amazing. But really, it's a 1 in 100 chance. So 2.50 came pretty good. So let's see what this temperature is. So the nearest tenth, it's going to be 21.1. And I'm going to write that temperature down, 21.1 degrees centigrade. So I can't have the end temperature of the water until I heat this up. So to heat it up, we actually are going to use, or I'm going to use, the burning chip. I'm going to move this stuff out of the way. This actually is way easier with a partner. I'm going to wing it a little to get this temperature. Now I have a Bunsen burner right here, which I'm going to keep away from the can because the Bunsen burner gets hot. And I do have a fire. See my fire? I'm going to use these tongs to hold the chip. I have to be ginger with it. I don't want to hurt it. And I'm going to light this chip on fire, and I'm going to let the chip burn underneath this can. And I'm going to do my best to get the fire only in the can. Try to get that heat in the can. Now, honestly, this is way easier with a partner. Now, the burning of the chip, the fire that's coming out of the chip, the energy that's coming out of the chip is raising the temperature of the water. The water takes a certain amount of energy to get hotter and hotter, right? The water has a specific heat capacity constant, 4.18 joules per gram dot Kelvin. We know how much water is in there. We weighed it, have the mass, and this heat is still going in, still burning, and we want to get all of the heat into the can, and it's going to heat the water up as much as it can. It's still burning, and that heat is going into the can. The water's getting hotter. I can't quite see exactly where it is, but we're nearly at 40 degrees centigrade. And I'm going to give this a little stir because the water at the bottom is probably hotter than the water at the top. And we want to get the average temperature. And now I got to keep watching and see if I get the highest temperature that it comes to. This stinks pretty bad. And we're at 39.8. That is how you measure the energy that's going to come out of the Dorito. Now, I have to do some math calculations. I'll do that in the second video to show you how to do this because you're going to have to do this. If you're at home, I'm going to give you all the data. And if you are in school, you're going to get your own data. Kind of exciting, kind of smelly. It stinks a little. You can't see that at home or smell it at home, but it smells like burnt Doritos. And I'm surprised kids eat them after they do this. It's like, oh, it's so gross. But anyway, the plan is to measure how much energy it took to raise the temperature of the water and say, hey, where'd that energy come from? It come from the Dorito. So we'll be able to figure out how much energy it took to raise the temperature of the water. We're going to convert those joules into cals and then convert those cals into food calories. And we're going to compare that to the nutritional information on the label and see how well we did, right? Because the official serving size of 28 grams, which nobody knows how much it is at home, they write 28 grams, it's 150 food calories. We'll see how much energy came out of this. Let me take a quick peek. Yep, that's about as hot as it got, 39.8. Okay, kids, over and out. I'll see you in the next video.